I'm going to discuss about BJT, that is bipolar junction transistor. Let us quickly go through the topics to be discussed: a brief history of BJT, introduction of BJT, how a BJT is constructed, how a BJT operates, the different configuration of transistor, how BJT can be used as a switch, and the different advantages of BJT. History. During 1904 to 1947, the vacuum tube was the electronic device of interest and development. In 1904, the vacuum tube diode was introduced by J. A. Fleming. On December 23, 1947, however, the electronic industry was to experience the advent of a completely new direction of interest and development. The first original transistor was invented at the Bell Telephone Lab. It is a point contact transistor, and the advantages of this three-terminal solid-state device over the vacuum tube is that it is smaller and lightweight. Also, it was more efficient since less power was absorbed by the device itself, and it is comparatively smaller in size. Also, it has low operating voltages. Now let's see what is a BJT. BJT is a three-terminal semiconductor device. It is a current control device, as the base current control the device. The operation depend on the interaction of both majority and minority carrier. Here the name is bipolar, as both majority and minority carriers are involved. It can be used in amplifier and oscillator circuit, and as a switch in digital circuit. It is comparatively smaller in size. Now let's see how a BJT is constructed. The transistor is a three-layer semiconductor device consisting of either two N and one P-type layers of material and two P and one N-type layers of material. It consists of a silicon or germanium crystal. It has two types, PNP and NPN transistor. This is the NPN transistor, where the P-type material is sandwiched between two N-type material. It has three terminal, emitter, base and collector. Here emitter is heavily doped, base is lightly doped, and collector is moderately doped. And this is the PNP transistor. Here N-type material is sandwiched between two P-type material. It has also three terminals, emitter, base and collector. And emitter, here also emitter is heavily doped, base slightly doped, and collector moderately doped. Now let's see the operation of a transistor. The basic operation of a transistor is described using this PNP transistor. So this is a PNP transistor. This is the emitter base junction. This is the base collector junction. In the emitter base junction, we have applied a voltage VEE, and in the base collector junction, we have applied a voltage VCC. So here both biasing potential have been applied to a PNP transistor, and the width of the depletion region indicating clearly which junction is forward bias and which is reverse bias. Since the sandwich N-type material is very thin and has a low conductivity, very small number of this carrier will take this path of high resistance to the base terminal, and the magnitude of this base current is typically on the order of microampere as compared to milliampere for the emitter and collector. This is a forward bias junction of PNP transistor. Here we have removed this VCC voltage from this base collector region, and in the emitter base region we have applied this VEE voltage. So this VEE voltage gives a forward voltage to this emitter base junction, and the majority carrier flow from emitter to collector. And this is the reverse bias junction of PNP transistor. Here the VCC VEE voltage is removed from emitter base junction, and VCC voltage is applied in base collector junction. Here this VCC voltage is the reverse voltage, due to which the depletion region increases. As the reverse voltage increases, that is VEE increases, the depletion region will also increase. So the minority carrier will flow from base to collector region. So in reverse bias junction, the depletion region increases. Now let's discuss the configuration of a transistor. There are three configurations of a transistor: common base configuration, common emitter configuration, and common collector configuration. Common base configuration, here base terminal is common to both input and output. Common emitter, here emitter terminal is common to both input and output. And in common collector configuration, collector terminal is common to both input and output. In common base configuration, emitter base is the input part, base collector is the output part. In common emitter configuration, emitter base is the input part, and collector base is the output part. So the output characteristics of transistor has three basic region: active region, cutoff region, and saturation region. In active region, emitter base is forward bias and base collector is reverse bias. In cutoff region, emitter base is cutoff region, that is reverse bias, and this base collector region is also reverse bias. In saturation region, both the junctions are forward bias, that is emitter base and base collector base. And in saturation region, a BJT can be used as a amplifier. Now, how BJT can be used as a switch? In cutoff region, BJT can be used as a switch where emitter base and base collector, both the junctions are reverse bias. So both the NPN and PNP type bipolar transistor can be made to operate as on-off type solid state switches by biasing the transistor base differently to that of a single amplifier. Now, what are the advantages of BJT over FET? BJT are characterized by linear current transfer function between the collector current and the base current. They have a large transconductance, and they can achieve much higher input signal gain as they are current control device. They have high speed and higher maximum frequency, so they prefer in amplifier circuit. They are used in very high speed logic circuits such as TTL and ECL, and it has high gain bandwidth. Also, it is very cost effective. So, at last we can conclude that the BJT can be used for low current application for switching purpose, as it is a current control device, and also BJT is a cheaper compared to this FET. BJT have low stray capacitance than power MOS, so they are sometimes used for audio and high frequency power amplifier in place of power MOS.